The developer's workflow has undergone a significant transformation with the advent of AI tools like Claude and Locofy. These tools have revolutionized the way developers approach coding, allowing for faster iteration and problem solving. Instead of spending hours on repetitive tasks or debugging, developers can now rely on AI to generate code, suggest improvements, and even anticipate potential issues. In this course, you will learn how to effectively integrate AI into your workflow. We will use Locofy for design-to-code conversion and Claude for animations and interactions. You'll build 2 screen designs in React Native with the help of these tools. You'll learn how to effectively prompt the AI, test and iterate on its outputs, and adapt the results to suit your project's needs. Although they are very efficient, developers still need a solid understanding of the basics of React Native to make the most of these technologies. AI helps in jumpstarting projects and accelerating workflows, but a foundational knowledge of coding principles remains crucial. These tools will only get better from here, making it an exciting time to integrate them into your development process. Adopting tools like Claude and Locofy has become essential, as those who don't leverage these advancements risk falling behind in productivity and innovation. The integration of AI into the workflow is no longer just an option. It's a necessity for staying competitive and efficient. We will begin with the responsiveness section, where you'll learn the importance of creating responsive designs that adapt seamlessly across different devices and screen sizes in Figma. You'll get hands-on experience in testing and adjusting designs to ensure they maintain integrity and provide an optimal user experience regardless of the device. The course then progresses to exporting your design to code using AI. Here, you will use the powerful Locofy plugin to convert your Figma designs into functional code. This section covers optimizing designs within the plugin, generating reusable components, and managing project files. We will also explore React Native CLI and Expo, comparing the 2 environments and guiding you on setting up and developing apps efficiently with Expo. This section will empower you to choose the best tools for your project needs. You will then learn to integrate version control with Git, ensuring you can manage your project's history and maintain a clean workflow. We'll walk through the basics of Git, from installation to managing repositories, committing changes, and reverting to previous versions. Then, the course introduces Claude Sonnet 3.5, an advanced AI model by Anthropic. You'll discover how to integrate Claude AI into your workflow to automate coding tasks, implement animations, and enhance your development process. We'll begin by familiarizing ourselves with the Reanimated Library and guide you through creating key animations. You'll learn to use functions like with Spring and with timing to build visually appealing and user-friendly animations. As we progress, you'll master more complex animations, including dynamic menu interactions, and explore how to seamlessly apply effects like fading, scaling, and translating components based on user interactions. By the end of this course, you'll have a deep understanding of how to build, test, and deploy high-quality React Native applications using AI as leverage. You'll be equipped not only with technical skills, but also with best practices and insights that will set you apart in your next mobile development project. Let's get right into it. The first step is to ensure the design is responsive. In today's world, where users access content across a multitude of devices and screen sizes, creating responsive designs is not just a best practice, it's a necessity. A responsive design ensures that your layout adapts seamlessly to various screen sizes, providing an optimal user experience regardless of the device being used. The importance of responsiveness cannot be overstated. In an era where mobile traffic often surpasses desktop, a non-responsive design can lead to poor user experiences, higher bounce rates, and ultimately, loss of engagement or sales. A responsive design not only enhances accessibility, but also improves SEO rankings, as search engines prioritize mobile-friendly sites. Let's start by testing the design by dragging its width. As you do this, you'll notice that the design remains static and doesn't adapt to different screen sizes. This indicates that the design is not responsive, so we need to fix it. To begin, duplicate the current design to create a reference point. Having a reference design helps us compare changes and ensure we maintain the original layout's integrity. Next, delete the status bar, which is only for showcase purposes and not essential for the actual design. Upon doing this, you'll observe that the navigation bar shifts upwards. This happens because the navigation bar is in an auto layout, which automatically adjusts based on the element's presence and arrangement. To maintain proper alignment after removing the status bar, we need to manually adjust the navigation bar's position. Use the reference design's height, which is 54 pixels, and apply this value as the top padding for the navigation bar. This ensures that the navigation bar remains correctly positioned, compensating for the removal of the status bar. Now let's focus on the screen's main content area. The central content block is already set in an auto layout with a vertical orientation, which is beneficial. The auto layout ensures that items within this block are evenly spaced, with the gap set to auto. This auto setting dynamically adjusts spacing, making it easier to maintain uniformity as items are added or removed. Flanking the main content are two similar menus on the left and right sides. To create a unified structure, we'll need to include these menus within the same auto layout as the central content. Begin by holding down the Shift key and selecting all three components: the left menu, the main content, and the right menu. Once selected, click on the auto layout icon to group them. This action will place all selected items into an auto layout, standardizing their spacing and alignment. After setting the auto layout, you may notice that the items have a horizontal gap of 0, as they were overlapping initially. We can reorganize the layout by dragging the gap handle to apply negative spacing until the design fits perfectly on the screen. Similar to the status bar, the home indicator can be removed since it is also meant only for showcase purposes. Deleting it will help maintain a cleaner design, especially if it's not part of the final interactive elements. Now, when testing the layouts, it's clear that the design is still not adaptive. This issue arises because the horizontal resizing properties need to be set to fill container. By setting elements to fill the container, we allow them to take up all available space in their parent container, making them flexible and capable of adapting to various screen sizes and dimensions. Starting with the navigation bar, you'll notice an issue where the controls text wraps awkwardly when the design is resized. This happens because the items are not correctly spaced. To fix this, we need to adjust the gap between these items. Currently, the title and content section are inside a frame, which can be restrictive for responsive design. To enhance adaptability, convert this frame into an auto layout to automatically manage the spacing and alignment of items. However, as we do this, we might see that some elements shift slightly. Auto layout ensures that items are spaced evenly, so if the layout appears asymmetrical, it's important to check the dimensions of each element. For instance, we noticed that the back button has a width of 70 pixels, while the settings icon measures 41 pixels. This discrepancy can create an unbalanced appearance. To correct this, set both the back button and the settings icon to the same width. Doing so not only enhances the visual harmony of the navigation bar, but also ensures consistency and balance. Once these elements are uniformly sized, set the gap between them to auto. This adjustment ensures that the space between elements is automatically calculated, allowing the design to flexibly accommodate different screen widths. This auto gap setting is particularly important for maintaining a polished look on various devices, as it adapts the spacing to fit the container perfectly. While addressing these layout issues, it's also a good time to refine the project's layer structure. Go through the layers and identify any that are redundant or unnecessary. Removing these extraneous layers not only simplifies the design, but also reduces the complexity of the underlying code. A cleaner and more organized project structure is easier to manage and makes future updates or adjustments more straightforward. This cleanup process helps ensure that the design remains efficient and maintainable over time. As with the navigation bar, the screen's content is also not yet adaptive. To allow for the fill container option, the parent container itself must be set to an auto layout. Let's apply an auto layout to the entire screen. After applying the auto layout, you might notice that the layout shifts again. This shift is caused by an element that's not visually affecting the design. Simply delete the unnecessary element to clean up the layout. Next, inspect the reference design to measure the distance between the navigation bar and the screen content. Apply the 10-pixel gap between these elements. This spacing ensures that there is a clear and uniform separation between the navigation bar and the main content area. With the auto layout and gaps in place, we can now set elements to fill container. Start by applying this setting to the navigation bar, allowing it to expand and contract with the parent container's width. This makes the navigation bar responsive to screen size changes, taking the full width of the available space. Then, apply the fill container setting to the screen content as well. However, this will require some additional adjustments to ensure everything adapts correctly. When examining the left menu frame, we notice that it contains a side menu and a rectangle shape embedded within it. In Figma, when using a frame as a parent container, we can utilize constraints to control how child elements behave when the frame is resized. By setting constraints, you can specify whether an object should maintain a fixed position, stretch, or scale in relation to its parent frame. It can be set for both horizontal and vertical directions, giving you precise control over the placement and scaling of UI components. Similarly, the right menu follows the same structure as the left. We'll set constraints for both the side menu and the rectangle to ensure they stick to the right side of their respective frames. This setup keeps these elements anchored to the right, maintaining their relative positions regardless of the frame's width. Next, we test our design and observe that the screen content is still not responding to changes in size. This issue arises because the main center content also needs to be set to fill container. By doing this, we ensure that the central content stretches and adjusts to the full width of the parent container, making it responsive to screen size variations. With the fill container setting applied to all relevant elements, the entire design becomes fully responsive. Now, when the outermost frame is resized, all contained elements adjust accordingly, ensuring a consistent and adaptive layout. When resizing the screen to a smaller size, we observe that a width of 360 pixels is the minimum width before the elements start to overlap. In auto layout, you can set a minimum and maximum width. These properties are essential for controlling the responsive behavior of elements within a layout. The minimum width setting ensures that an element doesn't shrink below a certain size, preserving readability and usability even on smaller screens. Conversely, the maximum width setting prevents an element from expanding beyond a specific size, which can be crucial for maintaining design consistency and preventing elements from becoming excessively large on wider screens. By defining both minimum and maximum width, designers can create flexible layouts that adapt to different screen sizes while maintaining a visually pleasing and functional design. To ensure the design remains clean and functional, we will set the minimum width to 360 pixels. For this project, we'll also set the maximum width to 480 pixels. This range ensures that the layout is responsive and maintains a good appearance across the specified width limits. Renaming layers correctly in Figma is crucial for maintaining an organized and efficient workflow, both within the design project and when preparing for code export. Clear and descriptive layer names make it easier to navigate complex designs, allowing team members and collaborators to quickly locate and understand different elements. This organization is particularly important in large projects, where multiple components and layers can become overwhelming. Additionally, properly named layers streamline the handoff process to developers, ensuring that exported assets are easy to identify and implement in code. Consistent and meaningful naming conventions help avoid confusion, reduce errors, and save time, ultimately contributing to a smoother transition from design to development. When working with SF symbols, you need to convert them into SVG or PNG format, as they are not currently supported by Locofy. The plugin will convert SVG files into PNG files, but you can always replace them manually later when customizing your code. Once your icons are exported, import them into Figma to replace the original icons. To do this, copy the new icon and use the Paste to Replace option to substitute it for the original one. You can use the hotkeys Command-C to copy and Command-Shift-R to paste and replace, streamlining the process. Repeat this procedure for all the icons in your design, including those in the navigation bar, the right menu, and the small chevrons in the Drive Mode section. This ensures all icons are correctly formatted and ready for export. Now, with the icons updated, we're ready to proceed to the next step, which is exporting the design to code using the Locofy plugin. Locofy is a powerful plugin that transforms Figma designs into functional code, bridging the gap between design and development. It significantly accelerates the process of exporting designs to code by automating many traditionally manual steps. You have the ability to optimize your design directly within the plugin, ensuring that elements are cleanly structured and ready for export. You can also create reusable components in the builder, which saves time and ensures consistency across different parts of the project. The plugin automatically generates folder structures and organizes assets, making it easier to customize the code and implement additional features. This includes handling images, icons, and other assets, placing them in the correct directories and linking them appropriately in the generated code. We will use this plugin to convert our design into code. In Figma, open the plugin menu and search for Locofy. Once you've installed the plugin, it will be accessible from the plugin menu. Select the frame you want to work with and create a new project. Name your project, then choose the type of project you're building. Select React Native from the mobile app menu. You'll then configure the code settings, where you can choose between using TypeScript or plain JavaScript, depending on your project's needs. Next, choose the environment. React Native CLI and Expo are two popular tools for building mobile applications using React Native, each offering unique features and use cases. React Native CLI provides complete control over the project's configuration, allowing developers to access and customize native modules and APIs. This toolchain is ideal for projects that require specific native functionalities, custom configurations, or integration with existing native codebases. It offers maximum flexibility but requires more setup and maintenance, as developers must manage native dependencies and configurations. Expo simplifies the development process by providing a managed environment with built-in APIs and services. It allows developers to quickly set up and develop applications without needing to manage native code. Expo is excellent for rapid prototyping, simpler apps, and developers who prefer a streamlined workflow. It includes features like over-the-air updates and the Expo Go app for easy testing. In summary, React Native CLI is suited for projects needing full customization and native feature access, while Expo is ideal for faster development and easier setup when the app's requirements match Expo's provided capabilities. If you're building a new app with React Native, we recommend using a framework like Expo. In short, you'll be able to spend time writing your app instead of writing an entire framework yourself in addition to your app. We'll be using Expo for this demonstration. Once the new project is created, you'll see all the steps the plugin provides to help us jumpstart the project. We will use this plugin to generate pixel-perfect code and lay the foundation for our work. While most of these steps will be completed during the coding phase later. Here is an overview of the process. The first step is optimizing your design within the plugin. This process includes cleaning up layers, ensuring proper alignment, and refining elements to ensure they are export-ready. Optimization helps in reducing unnecessary complexity and ensures that the design is structured correctly. Tagging involves assigning specific roles or components to different layers, such as image, buttons, or headers. This helps the plugin understand the purpose and functionality of each element, which in turn informs how these elements are translated into code. After tagging, you can edit the styling and layout of your design elements within Locofy. This includes fine-tuning properties such as colors, typography, spacing, and alignment to match the intended design specifications. The next step involves adding actions and interactions to your design elements. It allows you to define user interactions such as clicks, hovers, and transitions directly within the plugin. We will manage the styling and interactions directly in the project's code. All there is left for us to do in the plugin is to sync the design to the Locofy builder. This action transfers all your design components, styling, and interactions to the Locofy builder platform, where the actual code generation takes place. The builder converts the design into clean, production-ready code. This code can then be easily integrated into your development environment, significantly accelerating the development process and ensuring a seamless transition from design to implementation. Once in the builder, you can preview the prototype on the right side of the screen. This feature allows you to visualize and test your design as fully functional prototypes before finalizing and exporting the code. It's a valuable tool for real-time feedback, showing how the design behaves across different devices and screen sizes, helping to catch any issues early in the process. On the left side, you'll find all the framework files. This includes the code for the entire app, specific screens like the driving performance screen, and the global styles for the project. This organization helps in easily navigating and managing different parts of the application. On the right, alongside the prototype preview, you'll see additional steps that can be performed in the builder beyond what was available in the plugin. Here you have the option to refine and enhance the design further. The next essential task is to create components. React Native components are the building blocks of mobile applications developed using the React Native framework. These components are similar to widgets in other mobile frameworks and act as reusable elements with their own styling and functionality. React Native provides a rich library of built-in components such as view, text, image, scroll view, and text input, which handle common UI patterns and interactions. We can also create our own custom components, combining built-in ones and adding logic to suit our needs. By creating the components at this stage, the project's code structure and component files will be automatically set up for us. As we create components, the AI will suggest options for us to consider. We can choose to customize, reject, or accept these suggestions. For example, it has suggested the navigation bar and drive mode components, which we will accept. In the builder, you have the ability to directly select an element in the preview display, which will then highlight the corresponding code. This feature is incredibly useful for rapidly identifying specific elements you want to customize in your code. When you click on an element in the preview, it shows you exactly where it is defined and styled in the code. This streamlines the process of making targeted adjustments, as you can quickly navigate to the precise location in the code, view the applied styles, and understand their behavior. To start, let's use the layer panel on the left side to select an entire element. The goal here is to convert the design into components, making the code cleaner and more manageable. Begin by creating a component for the left menu. To do this, select the left menu in the layer panel and use the option to create a component. By turning the left menu into a component, you not only organize the code better, but also make it reusable across different parts of the project if needed. As you create a component for the left menu, observe how the code changes. The section of the code corresponding to the left menu becomes more concise and easier to read. This happens because components encapsulate their structure and styles, simplifying the overall code base. Next, repeat the process for the right menu. Select the right menu in the layer panel and create a component. Each component you create improves the code structure, making it increasingly clean and readable. The separation of concerns that components provide is crucial for maintaining a scalable and maintainable code base. Following the menus, we will focus on the power button. Select the power button element and create another component. This isolates its code, making it straightforward to locate and modify if any changes are needed. This isolation is particularly beneficial when dealing with interactive elements that might require specific behavior or styling. Finally, turn the speedometer image into a component. By the time all these elements are converted into components, the code for the screen will be much more organized. Each element's code is now encapsulated within its component, which significantly simplifies the overall code structure. With all these components in place, you'll notice a considerable improvement in the code's readability and manageability. The components we've created are what we will apply animations to. By turning elements into separate components, we not only make the code cleaner, but also simplify the process of adding animations and interactions. For instance, when animating the left menu, having it as a component means you can focus on just that part of the code without worrying about other elements. The same goes for the right menu, power button, and speedometer. This modular approach allows for targeted adjustments and animations, making the design more dynamic and interactive. Creating components also makes it easier to update and maintain the project in the future. If there are changes to be made to the left menu, you only need to update the component, and those changes will automatically propagate to every instance where the component is used. This efficiency is a significant advantage in both the design and development phases. By structuring the project with components in separate files, we enhance code readability and lay a solid foundation for applying animations and further customizations. The next step is to export our code. The plugin offers multiple options for syncing and exporting, depending on what you need. You can choose to export just specific components or the entire project. All the components we've created are listed, and you can select which ones you want to export. For this task, we'll choose to export the whole screen along with all its components. Once you've confirmed your selection, Locofy will begin preparing all the necessary files, including the assets, and will organize the project structure for you. This automated process saves a significant amount of time and ensures everything is neatly arranged. With the project files now ready, we can move on to the next step, customizing our code to fine-tune the design and functionality. In the zip file, you'll find all the exact same files as those in the builder. Every necessary file is included, making the project fully functional right out of the box. This package contains everything needed to run your project seamlessly, without any additional setup. To edit your code, you'll need an IDE, and we'll be using Visual Studio Code. It's widely popular and well supported, making it a reliable choice for this project. In the project folder, you'll find a README file created by Locofy. This file provides detailed instructions on how to run your application. But before you proceed, make sure you have Node.js installed on your system. Node.js is essential for running JavaScript on your server. Once installed, open the terminal in VS Code. You can do this quickly by using the hotkey command +backtick. With the terminal open, type npm install and press enter. This command installs all the necessary dependencies for your project, ensuring everything is set up correctly. If a message about vulnerabilities appears after the installation, don't worry. Simply follow the instructions provided in the terminal to fix it by running the given command. Now, to start the project, run the command npx expo start. This command will launch your application. Once the project is started, you have several options to view it. You can scan the QR code with your phone to see it live on an actual device. For this, you'll need to install the Expo Go app. You can also view the project on the web, Android, or an iOS simulator. In this case, we'll be using the iOS simulator. To set up the iOS device simulator for your React Native app, you'll need to install Xcode, which is Apple's integrated development environment, IDE, for Mac OS. Xcode provides all the necessary tools to develop, test, and debug iOS applications. Begin by downloading Xcode from the Mac App Store, ensuring you have the latest version. With Xcode installed, you can use the iOS simulator to run your project, making it easier to test and debug your app on different iPhone models without needing physical devices. Back in our project, you can press I to open the iOS simulator. Once the simulator is open, it will automatically launch our app, allowing us to see our design on an actual device simulation. This brings us one step closer to the final product. Now, let's explore the file structure that Locofy set up. First, we have the Assets folder, which contains all the project's assets, such as images and any other media our project needs. There's also a Convenient Components folder. This folder groups all the components we've created, making it easy to manage and reuse them throughout the project. Another important folder is the one for the project's screens. Right now, it only includes the driving performance screen, but as the project grows, this is where additional screens will be added. Lastly, we have a file dedicated to global styles. This file is crucial for maintaining design consistency across the entire project, ensuring that colors, fonts, and spacing remain uniform. Version control is an essential practice in software development, and Git is one of the most popular tools for managing version control. We will now focus on exploring the fundamentals of Git, a distributed version control system that allows multiple developers to work on a project simultaneously without interfering with each other's work. By using Git, you can track changes, collaborate with others, and revert to previous versions of your project when necessary. For this demonstration, we will focus on the basics of local version control, allowing you to test and iterate your code with confidence, knowing that you can always revert to an earlier version if needed. Before using Git, you need to install it on your system. You can download Git from their website and follow the installation instructions for your operating system. After installation, return to VS Code. The Expo project should still be running. To stop it, press Ctrl+C. You can now use the terminal to verify the installation by typing git version. This command will display the installed version of Git. To start tracking a project with Git, you need to initialize a Git repository. A Git repository is a version-controlled storage space that houses your project files and their entire change history, allowing you to track the project's evolution. Navigate to your project directory and run git init. This command creates a new subdirectory named Git that contains all of the necessary repository files. These files track the history of your project. The git status command is crucial for tracking the state of your working directory and staging area. It shows you which files have been modified, which are staged for the next commit, and which are untracked, new files that aren't being tracked by Git yet. This command provides a clear overview of what's happening in your repository, helping you decide your next steps in the version control process. Here, you can see that there are no commits yet, and all untracked files are displayed in red. Tracking means adding them to the version control system so that their changes can be monitored and recorded over time. To track a file or after making changes to your project files, you need to add them to the staging area before committing. The staging area is where Git temporarily holds files that are ready to be committed. To add files, use the command git add, followed by the file name. This moves your selected files to the staging area, preparing them for the next commit. If your terminal gets cluttered, you can clear it by simply typing clear. After adding files, check the status with git status to confirm. You'll see that the left menu component, or whichever file you added, is now in the staging area. If you need to unstage a file, use the remove or reset command followed by the file name. This removes the file from the staging area, but the changes you made remain in your working directory. If you want to unstage all files at once, just run git reset without specifying a file name. This will unstage everything without altering the actual modifications in your files. If we verify the status again, we can confirm that the file has been removed. This allows you to select which files are ready to be committed while keeping others in progress in the working directory. You can add multiple files by listing them, or add all changed files using git add followed by a dot. This command stages all the modified and new files for the next commit. Now let's learn how to commit changes to the repository. A commit in Git is a snapshot of your project's current state, capturing all stage changes and adding them to the project's history with a unique identifier and a descriptive message. To add all files to the staging area and commit at the same time, we can use the command git commit am, followed by the description of the commit. The A stages all tracked files that have been modified or deleted, so you don't need to manually use git add for each file. The M option allows you to directly add a commit message inline. Since this is our first commit, and we are committing all files, we describe it as such in the message. And just like that, we've made our first commit in the project's history. To see a history of all commits made to the repository, you can use git log. This command shows a list of commits along with details like commit hash, author, date, and the commit message. To see a simplified version, you can use git log one line. This command displays each commit in a single line, showing the commit hash and message. Now that our first commit is done, let's dive into the workflow and version control using Git. As you work on your project, Git is constantly tracking all changes made to your files. For instance, let's make a change in the speedometer gauge component by adjusting the dimensions of the speedometer image to 100 by 100 pixels. After making this change, restart your Expo project by running the appropriate command. Save the file, and you'll notice that the image has now been resized or shrunk to fit the new dimensions. To understand what changes have been made since your last commit, use the git diff command. Git diff is a powerful tool that allows you to compare your working directory with the last committed version. This tool is incredibly useful for reviewing changes before committing them, understanding what modifications have been made in your working directory, or even comparing different branches or specific commits. When you run git diff, the command shows line-by-line changes that have occurred in your files but haven't yet been staged for commit. It clearly highlights what's been added, modified, or deleted, helping you keep track of the exact differences between versions. For example, you'll see the last committed version in red and the recent changes in green. It also specifies which files these changes were made in. Press Q to exit the scroll view. When running the git status command, it will show you a list of modified files that haven't been staged for commit. This status check is helpful to ensure you don't miss any changes when you're ready to commit. Once you've reviewed your changes, you can proceed to stage and commit the file using the same command as before. This command stages the modified file and commits it with a descriptive message, capturing the change in the project's history. And that's it. You've successfully made another commit, advancing your project with careful version control. Now, let's take a look at our log. You'll see the 2 commits we've made so far, clearly documented in the project's history. If you need to revert your project to a previous commit, you can use the checkout command to temporarily view or work with an older version, or the reset command for a more permanent rollback. This allows you to explore an older version without affecting your current branch. However, you'll be in a detached head state, meaning any changes you make won't be saved to the branch unless you create a new branch from this commit. A branch is a parallel line of development that allows you to work on features, fixes, or experiments independently from the main project history. Here we are checking the latest commit. Let's go ahead and restart the Expo app. Next, we'll adjust the image dimensions once more, setting them to 200 by 200. After saving, the app displays the image's dimensions as applied. To keep changes but unstage them, use the command git reset, followed by the specific commit hash. This effectively keeps your modifications while removing them from the staging area. Running the git status command reveals that you are in a detached head state, indicating that the repository is not tracking the current branch, but is instead following a specific commit directly. If you want to discard the changes and reset your working directory, use git restore followed by the file name. To exit the detached head state and reattach to the main branch, use git switch main. This command will take you back to the main branch and restore your working directory to the state of the latest commit on main. We can see that the speedometer dimensions are now back to 100 by 100 pixels. The git status command confirms that you're now back in the main branch. To revert to an older version of your project, start by using the git log command to locate the desired commit hash. Once you have the hash, execute git reset, hard, followed by the commit hash. This action permanently reverts your project to that specific version. After performing the reset, you'll notice that the project has returned to its original state, where all files were first committed. Notice that the image is now back to 300 by 300 pixels. This feature allows you to experiment with different code changes and effects without fear, as you can always reset your project to a previous state. To make the most of this capability, commit your changes frequently, creating save points that you can easily return to. In conclusion, using Git locally for version control is a powerful way to manage your project's workflow. It allows you to track changes, experiment with new features and isolated branches, and easily revert to previous versions if needed. By keeping a complete history of your project on your local machine, Git ensures that you can work independently and confidently, knowing that your progress is safe and recoverable. This local version control workflow streamlines development and helps maintain the integrity of your codebase.